solve the equation x to the power of 4 plus 331,776 equals 0. X is a complex number. By rearranging the equation, we have x to the power of 4 equals minus 331,776. So x squared equals plus minus root of minus 331,776, which is equal to plus minus root of 331,776 times I. First, we separate the digits of the number into pairs, starting from the decimal point. In this case, that's just after 6. So the first pair is 7, 6. The next pair is 1, 7. The last pair is 3, 3. Next, we find the largest number whose square is less than or equal to the leftmost pair, which is 33. We find that it's 5. 5 times 5 is 25. The remainder is 8. Next, we drop down the next pair, which is 1, 7. Next, we multiply the quotient by 2. That is 5 times 2, which is 10. Now, we find the next digit of the quotient such that the divisor times this digit is less than or equal to this number. We find that in this case, this digit is 7. So we write 7 here and 7 here. Seven times 107 is 749, with a remainder 68. Next, we drop down the next pair, which is 76. Next, we multiply 57 by 2, which is 114. Now we find the largest quotient digits such that this number times this number is less than or equal to this number here. Note that this number and this number are the same. We find that the number is 6 in this case. Now we multiply 6 by 1,146, which is 6,876. Now we have a remainder of 0, so root of 331,776 76 is 576. So we can now write equals plus minus 576i. So either x squared equals 576i, or x squared equals minus 576i. That is x equals plus minus root of 576i, or x equals plus minus root of minus 576i, which is equal to plus minus I times root of 576i. Next, we work out root of 576. First, we separate the digits of the number into pairs, starting from the decimal point, which in this case is just after 6. So one pair is 76. Next, we find the largest number such that the square of this number is less than or equal to 5. We find that the number is 2 in this case, and we write 2 here and 2 here. 2 times 2 is 4. 5 minus 4 is 1. Next, we drop down the next pair. Next, we multiply the quotient digits 2 by 2, which is 4. Now we find the next quotient digits such that this number times this number is less than or equal to this number. We find that the next quotient digit is 4, so we write 4 here and 4 here. 4 times 44 is 176. We have a remainder of 0. So root of 576 is 24. So either x equals plus minus 24 times root I, or x equals plus minus 24i times root I. Now let root I equal t plus s times I. Then root I all squared equals t plus s times I all squared. Root I all squared is equal to I t plus s times I all squared is equal to t squared minus s squared plus 2ts times I. On the left hand side of the equation, we have I. On the right hand side of the equation, we have t squared minus s squared plus 2ts times I. So t squared minus s squared must equal 0, and 2ts must equal 1. From equation 4, t must equal plus minus s. Now substitute t equals minus s in equation 5. We have minus 2s squared equals 1, which is false. Next, substitute t equals s in equation 5. We have 2s squared equals 1. So s equals plus minus 1 over root 2. T equals plus minus 1 over root 2. Thus, root I equals 1 over root 2 plus 1 over root 2 times I, or root I equals minus 1 over root 2 minus 1 over root 2 times I. Next, substitute root I equals 1 over root 2 plus 1 over root 2 times I. In equation 2, we have x1 equals 24 times root I, which is equal to 24 times 1 over root 2 plus 1 over root 2 times I, which can be written as 12 root 2 times 1 plus I. x2 equals minus 24 times root I, which can be written as minus 24 times 1 over root 2 plus 1 over root 2 times I, which can be written as minus 12 times root 2 times 1 plus I. Now substitute root I equals 1 over root 2 plus 1 over root 2 times I. In equation 3, we have x3 equals 24I times root I, which is equal to 24I times 1 over root 2 plus 1 over root 2 times I, which can be written as minus 12 times root 2 times 1 minus I. x4 equals minus 24I times root I, which is equal to minus 24I times 1 over root 2 plus 1 over root 2 times I, which can be written as 12 times root 2 times 1 minus I. Next, substitute root I equals minus 1 over root 2 minus 1 over root 2 times I. In equations 2 and 3, we have the same four solutions, that is, plus minus 12 times root 2 times 1 plus I, plus minus 12 times root 2 times 1 minus I.